A yeast culture at a room temperature 68°F is placed in a refrigerator set at a constant temperature of 38°F. After the T hours, the temperature T of the culture is given approximately by this equation over here as T equal to 30 times e to the power minus 0.58 T plus 38. And this is valid for when T is greater than or equal to 0. The main question here is, what is the rate of change of the temperature, right? So what is the rate of change of the temperature of the culture at the end of 1 hour? So you can clearly see here we have been given a scenario here where the temperature of the culture is approximated by this equation over here, right? So we have given that, and our goal is to find the rate of change of that temperature of the culture at the end of 1 hour. So how do we work on this question? As we know that the key question here is to find the rate of change of the temperature, and then we have given a temperature function over here, and we know that the rate of change of any function can be figured out by finding the derivative of the function. So on this case, then to find the rate of change of the temperature, we can differentiate the temperature with respect to time, right? So let's try to do that. So how do you then find the derivative of the t with respect to t? We have a constant here multiplied by a function, so we can actually use the constant multiple rule, which is leave the constant as it is and multiply by the derivative of this function, and that function here is given as the exponential function composed with negative 0.58 times t. So if that is the case, we need to use the chain rule, right? So because there is a composite function, so what is the derivative then? By using the chain rule, since the exponential function composed with some functions, so the derivative will be can be written in this way. We write down the derivative of the exponential function, which is e to the power x, e to the power t. In this case, it is composed with negative 0.58 times t. So let's compose that. So on that case, we will have negative 0.58 e to the power negative 0.58 times t. But since this is composite function, because of the chain rule, we need to actually multiply by the derivative of negative 0.58 t with respect to t, and that will be here just negative 0.58, right? So this is the derivative of this first term, and then plus what is the derivative of the constant? The derivative of the constant is just 0. So you see that here if we have this given function, this temperature function, and then we figure out the derivative of that with respect to t, which will help us to calculate the rate of change of the temperature for any given time, right? Because this is already now the rate of change function. If you want to simplify this little bit, we can just multiply these two numbers, 30 times negative 0.58. If you multiply that together, we get negative 17.4, and then times e to the power negative 0.58 times t. So we can write down on this alternative form or the simplified form, but our main job here is to find the rate of change of the temperature of the culture at the end of the 1 hour. So that means we need to find the derivative of t with respect to t, or with respect to the time when the time is 1. So how do you find this? We already have the rate of change function here, right? And then this is depending on that the time t. If that is the case, we just need to evaluate that at t equal to 1. So then what we just need to do here is just write down the function and then try to see if we can evaluate that at 1. So how do you do that? So if this is the function that will give you the rate of change, we just need to replace t by 1, right? So in that case, 17.4 is as it is. Write that down, and we have e to the power negative 0.58 times t, and then t is 1, so just replace that by 1. So what is the answer we get? Negative 17.4 times e to the power negative 0.58 will be approximately, let's say, equal to negative 9.7422, 2, right? So that is the rate of change of the temperature of the culture at the end of 1 hour, and that's our answer.